Okay, so for number 1, you see that we have power to power right here, a power to a power. So we're going to multiply those together. So you get 1/16 to the negative 2/3 times 3/4. So 3/3 cancels, and then 2/4 is 1/2, and there's a negative there. So then this becomes 1/16 to the negative 1/2. Okay, so I should put parentheses there. And if you want to make it positive 1/2, remember you take the reciprocal of the base. And 1/2, the 16 to the 1/2 means a square root of 16. So this is 4. Okay, so number 2, you have in the numerator the same base raised to different powers. So we have to take this one and this one and add them together. Again, the bases are the same, and we're multiplying. So we get x to the 1/3 plus 5/6. And for now, I'll just leave the 1/6, the denominator, alone. So common denominator of 1/3 and 5/6 is 6. So the first one becomes 2/6 plus 5/6. So I've got x to the 7/6 over x to the 1/6, and then when you're dividing, you subtract the powers, right? So this is x to the 7/6 minus 1/6 minus, so that's x to the 6/6, which is x, because it's x to the first. So again, the numerator has the same base, 9 and 9, so I'm going to add the exponents. So it's 9 3/2 plus 1/2, and for now I'll leave the denominator alone, and so that gives you 4/2, which is 2. Okay, so now I'm going to subtract 2 minus a negative 2, because that's what the denominator is. So that's 9 to the 4th. And 9 to the 4th, when you punch it in a calculator, is 6,561. Okay, so I'm going to distribute the outside exponent, this one, to here and here. So that gives me 16 to the 5/3 times 9/5. And in the denominator, 16 5/6 to the 9/5. Okay, so I distributed the 9/5 here and here, top and bottom. And so then the 5/5 cancels, 5/5 cancels, and so you're left with 16 to the 9/3, which is 3. And in the denominator, 16 to the 9/6, right? Because you have 9/6. So I'm going to reduce it by 3 and get 3/2. So when you subtract 16, 3 minus 3/2, that's 1.5. That leaves us with 3 minus 1.5 is 1.5, right? So, or 3/2. And so square root of 16 raised to the 3rd power. So that's 4 to the 3rd, 64. Alright, so for 5, I'm going to leave the numerator alone for now, and I'm going to distribute this exponent here and here. So I get x 1/3 times 3/2 times y 2/3 times 3/2. So the 3 and the 3 cancel, 3 and the 3 cancel, 2 and the 2 cancel, so you're left with 2xy over x to the 1/2 y to the 1st. So then this y and this y cancel, and so now I have to remember this is a 1, right? So 1 minus 1/2, because that's the exponent here, and 1 is here and 1/2 here. So you're going to get 2 x to the 1 minus 1/2. So it's 2 x to the 1/2. Okay? And that would be how you write the answer. So for this problem, the only thing that has to be simplified is the y, because there's only the 3 and the 2 don't reduce anymore, right? And then there's only one x down here. So I'm going to simplify this. So let me just write it right here. 3/4 minus 3/2, 2x. So common denominator is 4, so I'm going to multiply this by 2 over 2. So this gives me y to the, so now this is 6, right? Right here. 3 minus 6 is negative 3 over 4, 2x. Now usually we keep the variables with a, let me see, did I copy it right? Yeah. With a positive, so, excuse me, we want the exponent to be positive, not negative, so we're going to bring it back to the bottom. So 3 over 2x y to the 3/4. And another thing that we can have, we could only have like whole number powers in the denominator. That's called rationalizing the denominator. So I'm going to multiply, this is something that we'll talk about more on Friday. I'm going to multiply both top and bottom by y to the 1/4. And why is it y to the 1/4? Because when you do that, when you combine these two, you get y to the first, right? 4 over 4 is 1. And so you end up with a whole number exponent for y in the denominator. So you have y to the 1/4 over 2xy. This would be the final answer. Alright, so number 7, the first thing I'm going to do is change it from radical to rational exponent. So this is going to be 25 to the 1/4 times 5 to the 1/3. Now remember, I cannot add these exponents because I've got 25 and 5, right? They're not the same base. So I've got to, figure out a way to get the same base. So I know that 25 is 5 squared, so I'm going to rewrite it as 5 squared to the 1/4. And so 2 times 1/4, because see how it's power to power? 2 to the 1/4 is 2 times 1/4, so that becomes 5.5, because 2 over 4 is a half. And so now I could add the exponents. So 1/2 plus 1/3 becomes 5 to the, I gotta multiply this by 3 over 3 to get a common denominator, and 2 over 2. So 3 plus 2 is 5 over 6. So again, for 8, I'm going to go ahead and change it to a rational exponent. So this is 2, negative 2 over 4. I'll just write it like this and I'll simplify later. And this would be 2, negative 9 over 6. So then 2 to the negative 1/2 over 2 to the negative 3/2. So I'm going to now subtract the exponents. So 2 negative 1/2 minus a negative 3/2. So then that gives me positive, right there, positive 3/2. So 3/2 minus 2/2 is 2/2, right? 3 minus 1 is 2. So 2 over 2 is 1. So it's just 2. So I'm going to go ahead and change it to rational exponents. So this is 3 to the 3/4 times x to the 2/3 over, now since the 3x in the denominator is inside the square root, it becomes 3 to the 1/2 times x to the 1/2, because they were both inside the radical. So they each have the exponent 1/2. So now I'm going to do 3 to the 3/4 minus 1/2 times x to the 2/3 minus 1/2. Okay, so in the first set right here, 3/4 minus 1/2, the common denominator is 4. So I'm going to multiply by 2 over 2. So 3 minus 2 is 1. So this is 3 to the 1/4. And then right here, the common denominator is 6. So I'm going to multiply this by 3 over 3. This one by 2 over 2. So I get 4 minus 3, which is 1. See, right here, 2 times 2 is 4. 1 times 3, 3. So x to the 1/6. So that would be the final answer. Okay, so I'm going to get rid of the radical and use rational exponents. So first one is x. Now remember it's 4 over 4 times, and then y is going to be 6 over 4. And we'll simplify at the end. And then right here it's going to be 6. Now when there's nothing there, we know that it's a 2, right? So it's going to be x 6 over 2, and the denominator is just y. So the first one is x, then y to the 3/2, then x cubed over y. So I'm going to combine this one and this one because they're both x's. So that's going to give me x to the 4th. And then the y's, I'm going to do 3/2 minus 1 because the denominator, the power right there is 1. So 3/2 minus 1 is the same thing as 2/2, right? Because that's 1 over 1 for times. So 3 minus 2 is 1, and so 1 over 2. So the answer is x to the 4th, y to the 1/2. Alright, first thing is, again, just like in the previous ones, we're going to change the radical to rational exponents. So I have s to the 4/6 times t to the 9/6 over, and again, because s and t again are inside the radical, they each have they're each cube root. So this is s to the 1/3, t to the 1/3. Okay, so now we're going to subtract. So s, I can change, the 4/6 is actually 2/3, right? So 2/3 minus 1/3. And then the t's, 9/6 is actually 3/2 when you reduce it, so 3/2 minus 1/3. So for s, it's 2/3 minus 1/3, so that leaves you with 1/3. The t is just a little bit of work here. I've got to get a common denominator, so I've got to multiply 2 over 2 here to get a 6, and this one 3 over 3 to get a 6. So this gives me 9, and this gives me 2, so 9 minus 2 is 7. So t to the 7/6, because the denominator is 6. So right here is the answer. Okay, for this one,